I'm Fleshed Out Thoughts, and I love fleshing out thoughts for extended periods of time. And I'm building a full stack e-commerce platform for digital products and software services with Next.js and Supabase. This series is about the architectural decisions behind the platform, what I built, why I built it that way, and what I do differently. Today, we're going to be getting into proxies, forward, reverse, and CDN proxies in my Next.js e-commerce platform. Every HTTP request you make passes through at least one proxy. Your browser request goes through your ISP's network gateway. Your server response goes through Vercel's CDN edge, then Vercel's routing layer, then Next.js's middleware/proxy. 3 hops before your server action runs. If you don't understand the proxy chain your request travels through, you'll write code that makes your wrong assumptions about which IP address is actually the client, why you're seeing the HTTP request inside an HTTPS application, and why your rate limiter isn't working correctly. This video is about understanding the proxy chain, forward proxies, reverse proxies, CDNs, and the specific hops in Vercel's infrastructure, so you can write code that works correctly with that chain rather than against it. Forward versus reverse proxy. A forward proxy acts on behalf of the client. The client sends requests to the forward proxy, which forwards them to the internet. The internet sees the proxy's IP, not the client's. The client's identity is hidden from the destination. Corporate networks use forward proxies to filter outbound traffic. VPNs are forward proxies. Privacy tools are forward proxies. A reverse proxy acts on behalf of the server. The client sends requests to the reverse proxy, which forwards them to the server. The client sees the proxy's IP, not the server's. The server's identity and location are hidden from the client. Load balancers are reverse proxies. CDNs are reverse proxies. Vercel is a reverse proxy. From your application's perspective, when you deploy Vercel, your Next.js server is behind Vercel's reverse proxy. Your server action never receives the client's request directly. It receives what Vercel's proxy forwards. That distinction is why you can't trust the raw IP address in the request and why you see HTTP internally on an HTTPS application. The SVG shows 3 proxy types in my platform's request lifecycle. An outbound request from my server, for example, call to Stripe, passes through a forward proxy. Inbound requests from users pass through Vercel's CDN edge as a caching reverse proxy, then through Vercel's routing layer as a request forwarding reverse proxy. In the middle, Supabase sits behind its own reverse proxy infrastructure. Every significant hop adds headers that tell the downstream system what the previous hop saw. The X forwarded for header accumulates a history of IP addresses as the request travels through each proxy. Understanding this chain is what makes reading those headers correctly possible. Vercel's proxy chain. A request from a user's browser makes 3 hops before reaching your server action. Hop 1. Browser to Vercel's CDN edge. TLS is terminated here. The HTTPS session the user established ends at the edge node. For ISR cache page, the edge serves the response directly. Your origin server receives 0 requests. For dynamic requests, the edge forwards to the next hop. Hop 2. CDN edge to Vercel origin router. Vercel's internal routing layer. It determines which serverless function to invoke. It adds proxy headers, X forwarded for, with the client's IP, X real IP, X forwarded proto, and others, to the forwarded request. Hop 3. Origin router to server actions. Your code runs here. Headers.get X forwarded for reads the header set by hop 2. The critical question: can you trust the value you read? X forwarded for spoofing. X forwarded for is a comma-separated list of IP addresses. Each proxy appends its own address as it forwards the request. The first value is supposed to be the original client IP. The last value is the most recent proxy. Here's the attack. The attacker sends a request with a custom X forwarded for 1.2.3.4 header they've chosen. Vercel's proxy receives the request and appends the attacker's real IP, producing X forwarded for 1.2.3.4.5, and so on. Your code reads split and gets 1.2.3. The attacker's real IP is in the list, but you're not reading it. Your rate limiter key is on the forged first value, and the attacker simply changes the first value on every request to bypass the limit entirely. The fix is to read the last value, the one your trusted proxy added, or to use xreal IP, which Vercel sets to the connecting IP and which the client cannot forge one more time. The fix is to read the last value, the one your trusted proxy added, or to use xreal IP, which Vercel sets to the connecting IP and which the client cannot forge. Xreal IP is set by the proxy after it receives a connection. The attacker cannot influence it without controlling the proxy node itself. TLS termination. The user connects to your site over HTTPS. Inside your server action, the request URL shows http:// not HTTPS. This is TLS termination. The HTTPS session ends at the CDN edge, and the internal transport from the edge to your server is different. When the edge node decrypts the request, it reads the header and body. It then creates a new connection to your origin server. This new connection may be HTTP or an encrypted internal transport, but it's not the same TLS session the user established. 4 implications for your code. Don't implement HTTP-HTTPS redirects in server actions. Vercel handles this at the edge before the request reaches you. To check whether the original client used HTTPS readx forwarded proto. It is set by the proxy after TLS termination and it's reliable. Set the secure attribute on all cookies, even though internal transport is HTTP, the cookie is sent to the user over their HTTPS connection. Trust X forwarded proto. It's set by Vercel's trusted infrastructure, not by the client, so it can't be forged. CDN as a caching proxy. The CDN is a reverse proxy that makes a decision on every request. Served from cache or forwarded to origin, your cache control headers are the instructions you give it. Cache control public S max age 3600. CDN caches for 1 hour. All requests for this URL served from the edge. Your origin receives 0 requests during that window. Cache control private. CDN must not cache every request forwarded to origin. Used for authenticated user-specific responses. Cache control no store. CDN doesn't cache and doesn't store. For order status, payment confirmations, etc. No cache control header. CDN behavior is undefined. Each vendor has different defaults. Vercel caches some content types by default. Always set explicit cache control. When CDN cache becomes a problem, stale data served to users, right? The fix from server action is revalidate path, which triggers a cache purge for a specific URL after data mutation. This is the correct pattern for code locating data mutation and cache invalidation. Middleware as an application proxy. Next.js middleware is an application layer proxy. It runs at the edge between the CDN and your server component and can read requests, modify headers, redirect, rewrite URLs, or respond directly. In proxy terms, middleware intercepts every request, applies logic, and either forwards to the next step or responds. That's exactly what a proxy does. My middleware does 3 things. It refreshes the Supabase session, reads the session cookie, verifies with auth server, sets refresh tokens in the response cookies. By the time any server component renders, the session is already verified and fresh. Second, it checks route protection. If the route requires authentication, then there's no session. Redirect to the log page. This redirection happens before any server component renders, preventing unauthenticated rendering entirely. Third, it forwards the request with all updated cookies. The performance implication. Middleware runs at the edge node, close to the user. A redirect decision in middleware doesn't require a round trip to the origin server. It's resolved at the edge. Proxy headers reference. 6 proxy headers and what each one means. X forwarded for comma separated IP list. First value is the original client IP but can be forged by the client. The last value is added by your proxy and is reliable. Trust the last value only. Xreal IP. Single IP set by Nginx or Vercel. The connecting IP overriding any client provided value. Prefer this over X-Forwarded for rate limiting. Fully trusted. X-Forwarded Proto. Original protocol before TLS termination. HTTPS means the client was on HTTPS. Fully trusted. Set by the proxy after TLS handshake, not by the client. X-Forwarded host. Original host header before any proxy rewrites. Trust partially. Validate against your known domain list. CF connecting IP. Cloudflare specific header for the real client IP. Only present if Cloudflare is in the proxy chain. Fully trusted if Cloudflare is your proxy. Forwarded. The RFC 7239 standard that combines X-Forwarded into one header, not just universally supported. Same trust rules as X-Forwarded for. Alright. The following principle. Only trust headers set by your own proxy infrastructure. Headers the client can't inject before your proxy receives the request cannot be trusted for security decisions. Summary. Every request passes through a proxy. Forward proxies acts on behalf on the client. Hides the client's identity. VPNs, corporate gateways. Reverse proxies act on behalf of the server. They hide the server's location. Vercel and CDN are reverse proxies. Never trust X-Forwarded for. X-Forwarded for sub-0. Clients can set any value they want. The attacker sets 1.2.3.4. Your proxy appends to the real IP, but you read the forward first value. Use X-real IP or read the last value in X-Forwarded for. TLS terminates at the CDN edge. Your server action receives HTTP internally. Check X-Forwarded Proto for the original protocol. Don't implement HTTP-HTTPS. This redirects in server actions. Vercel handles this. Cache control headers are instructions to the CDN proxy. Always set them explicitly. Underdefined CDN behavior produces hard to reproduce caching bugs. Revalidate path triggers cache purge from server actions. Middleware is an application layer proxy at the edge. It runs before any rendering. Session verification in middleware prevents unauthenticated server components from rendering, not just unauthenticated data access for the client. This platform's request path passes through Vercel CDN edge for TLS termination and ISR caching, Vercel's routing layer for header injection, and Next.js middleware for session refresh and route protection. Before reaching a server action, client IP is read from X-real IP, not X-Forwarded for sub-0 to prevent spoofing. I'm Fleshed Out Thoughts, and I'm building a full-stack e-commerce platform for digital products and software services with Next.js and Supabase. If you're working through proxy configuration, header trust decisions, or middleware design for your own platform, please reach out. I'm open to freelance projects and consulting. The full post is linked in the description below. Complete proxy header reference and X-Forwarded for implementation and the middleware walkthrough. The next in this series, async system design, the outbox pattern, item potency, and what I'd add at scale. I'll see you there.